Okay, now according to Lewis concept, you have got the acid and bases. Now, Lewis acid, Lewis acid also includes Lewis acid also includes the following. I'll give you some examples of Lewis acid. Number one, Lewis acid. All cations, cations means the positive ions like Na plus ion, H plus ion, hydronium ion, this type of ions, any positive ion, they always act as acid according to Lewis concept. And why these positive ions act as acid? Because positive means what? They have deficiency of electron, and due to deficiency of electron, they can accept the electron pair, and that is why this type of positive ion always act as base. That is why if you get some positive ion, that type of positive ion always act as acid because they can accept a pair of electron, and that is why all cations are act as acid. Number two, these are acid. These are the example of acid. The molecules like AlCl3, which is called aluminium chloride, then BCl3, which is called boron trichloride, then BF3, which is called boron trifluoride. These also act as Lewis acid. To become acid, there must be hydrogen in the compound, but you see AlCl3, BCl3, BF3, this type of compounds do not have any H plus ion, but although they have no H plus ion, they can act as acid. Now, why they can act as acid? In case of aluminium chloride, as you know, aluminium atomic number is 13. 13 means it contains 3 valence electron like this. When it shares with chlorine, chlorine contains 7 electrons in its valence shell. This is one chlorine, and this is one chlorine, 7 electrons in the valence shell, and this is another chlorine, 7 electrons in the valence shell. So when the sharing of electron takes place, since chlorine requires 1 electron, and that is why sharing will take place like this, and in this process the covalent bond will form between aluminium and chlorine. Now after sharing, see the aluminium, inside aluminium how many electron? Here 2 electron, here 2 electron, here 2 electron, total number of electron becomes 6. When some element form compounds, then inside the central atom there must be 8 electrons, which is called octet rule. But there are so many compounds in which the central atom do not complete the octet. They do not follow the octet rule. Although aluminium do not have octet, 8 electrons, but it can form the compounds. So due to this reason, aluminium have electron deficiency. It should have 8, but here there are 6 electrons. And that is what, in this type of molecule, the central atom can gain one more pair of electron to become 8. As you know, according to Lewis concept, the substance which can gain a pair of electron, they always act as acid. So since aluminium can gain one pair of electron, that is why AlCl3, BCl3, BF3, this type of molecule act as your Lewis acid. Those molecules in which the central atom have electron deficiency, this type of molecule always act as Lewis acid. Have you got it? So that is why AlCl3, BCl3, BF3, this type of molecule act as acid. Number 3, carbon dioxide, sulfur dioxide, sulfur trioxide, this type of molecule also act as acid according to Lewis concept. Now why carbon dioxide, sulfur dioxide, your sulfur trioxide, this type of molecule act as acid? According to Lewis, as you know, carbon dioxide contain double bond with oxygen like this, and it has the linear structure. Here the bond is present between carbon and oxygen, and these are covalent bond. By sharing of electron, they produce the bond. As you know, oxygen is highly electronegative. Due to more electronegativity of oxygen, it will attract the bonded electron towards itself. So when both the oxygen will attract the bonded electron towards itself, then some deficiency of electron takes place inside carbon, and due to this deficiency of electron inside carbon, carbon can gain one pair of electron from outside, and that is why carbon dioxide, sulfur trioxide, this type of molecule can act as acid. I mean those molecule in which some multiple bonds are present, I mean double bond, triple bonds are present between two different electronegative atoms, that type of molecule always act as acid. I mean one atom should be more electronegative, one atom should be less electronegative, and in between them there must be some double bond or triple bond, then that type of molecule always act as acid, because inside the central atom it has electron deficiency. Why it has electron deficiency? Because the surrounding atom attract the shared pair of electron due to more electronegativity character. So this type of molecule also act as acid. So these are the examples of Lewis acid. Similarly, some molecule, this will be number 4, some molecule like PCl3, PCl5, then SiCl4, silicon tetrachloride, this type of molecule also act as acid. This is called phosphorus trichloride, 3 chlorine present, that's why trichloride. This is called phosphorus pentachloride, this is called silicon tetrachloride. This type of molecule also act as acid. Why this type of molecule act as acid? If you consider PCl3, here central atom is phosphorus, and as you know phosphorus atomic number is 15. If it is 15 atomic number, then the configuration will be 1s2, 2s2, 2p6, 3s2, 3p3. This is the electronic configuration of phosphorus. Now, as you know, 1s it is present in first cell, I mean K cell, 2s and 2p they are present in second cell, 3s and 3p they are present in third cell, I mean M cell. You know, first cell contain only one subcell, that is 1s, second cell contain two subcell, 2s and 2p, third cell contain three subcell, 3s, 3p and 3d. Here 3d also present, but there are no electron, here d orbital is vacant. So this type of atom contains some vacant d orbital in the outermost shell, and due to presence of vacant d orbital, as you know there are 5 d orbitals like this, these are all vacant. So those molecules in which the central atom contains some vacant d orbital like this, due to presence of the vacant d orbital, they can accept some electron pair from outsource like this, and that is why this type of molecule PCl5, PCl3, SiCl4 they always act as acid. I mean the molecule in which the central atom contains some vacant d orbital, that type of molecule act as Lewis acid. So these are the examples of Lewis acid. In exam you will get the question like this: identify the Lewis acid and Lewis bases from the following. So you will get number of examples, and from the example you have to identify who will act as acid, who will act as base. So these are Lewis acid. Now I will give you some Lewis bases. Lewis bases includes the following. Number 1 point, all anions, as you have got all cations, I mean positive ions, they act as acid. All anions, I mean negative ions, they act as Lewis base. For example, Cl minus, Br minus, I minus, CH3, CO minus, Cl minus, any negative ion, they always act as base. And why they act as base? Negative means they have electron rich, I mean they have extra electron, and due to presence of extra electrons they can donate the pair of electron, and that is why all anions act as Lewis base. Similarly, number 2, those molecule, for example water, here who is the central atom? Oxygen. You know oxygen always have 2 lone pair of electron. Ammonia, who is the central atom? Nitrogen. Nitrogen contain 1 lone pair of electron. H2S, sulfur contain 2 lone pair of electron. Then PH3, phosphorus contain 1 lone pair of electron. This type of molecule in which the central atom contain lone pair of electron, they also act as Lewis base, because due to presence of lone pair of electron they can donate the lone pair of electron to someone, and that is why this type of molecule always act as base. So according to Lewis concept, all anions are bases, and those molecules in which the central atom contains some lone pair of electrons, they also act base, and that is why water, ammonia, H2S, pH3, they act as bases. In class 10 you have got the substances which can release OH minus ion, they only act as base, but here they do not have any OH minus ion, but they can act as base. Why? Because they can donate the lone pair of electron. So that is why this Lewis concept is said to be the modern concept. It based on mainly electrons, it do not depends on the H plus ion and OH minus ion. So these are the examples of Lewis acid and bases, and now you can identify who will act as Lewis acid, who will act as Lewis bases. Thank you.